Hello everyone, today I'm going to explain how to calculate the amount of chemical needed for transesterification. And last time we talked about the transesterification as a process that can be used for producing fatty acid esters, which is biodiesel. And we said that 1 mole of triglyceride should be reacted with at least 3 moles of alcohol, in this case methanol. And in the presence of catalyst, we can produce the biodiesel and the glycerol. And we said that this is basically, we use at least 3 mole of methanol to 1 mole of the triglyceride or 1 mole of oil. Of course, to calculate this amount of chemicals, we have to calculate the molecular weight. The molecular weight of vegetable is needed. And the oil vary in fatty acid composition depending on oil source, and even if we have different cultivar, it might actually also affecting the composition of the oil or the fatty acid profile of the oil. Therefore, there is no defined molecular weight of all vegetable oil, but we can just calculate an average molecular weight of oil based on the profile of different fatty acids contained in the oil. Okay? How to calculate the molecular weight if we have this kind of reaction for hydrolysis of triglyceride in the presence of water, we can produce glycerin and 3 fatty acids. So this is basically the standard hydrolysis of triglyceride. And to calculate the molecular weight of vegetable oil, which is a mixture of fatty acid glycerol ester, so we have to use this equation, which is basically a mass balance. If we have, this is the average molecular weight of vegetable oil plus 3 molecular weight of oil of water equal to 3 molecular weight of average fatty acids plus molar weight of glycerol. So in other words, that the average molecular weight of vegetable oil equal to 3 molecular weight or average molecular weight of fatty acids in the oil plus molecular weight of glycerol minus 3 molecular weight of water. This equation actually taken from this reference here, and you can actually go back and read more about this. Okay, but again, to get this average molecular weight of oil, we have to do the profile. So basically, the overall average molecular weight of vegetable oil can be calculated from this equation. Why? Because basically, as I mentioned, we have different fatty acids in the oil, so we have to use the molar ratio or the mass fraction of particular fatty acids divided by the molecular weight of that particular fatty acid. In other words, that the reciprocal of molar weight of the average fatty acids of the whole oil, this is basically the average, equal to the summation of the mass fraction of particular fatty acids in the oil. If we have linoleic or other fatty acids in the oil, so we have to have the mass fraction of it divided by the molecular weight for this specific particular or this is particular fatty acids. And if we have other fatty acids, the same thing. So basically, we repeat actually the this ratio. Say this is if we have 5 or 6 or more. So basically, the mass fraction of fatty acid 1 divided by its molecular weight plus mass fraction of fatty acid 2 divided by its molecular weight, and so on and so forth until we get to the total amount of the or total type of fatty acid inside in the oil sample. Okay, how to do this? So basically, this is example also taken from the same book, and this is the molecular weight of soybean. And if we have a farmer had a soybean analyzed by commercial lab, and they give, of course, this commercial lab use gas chromatography and gives the fatty acid profile as follow. The soybean has palmitic acid 9%, and stearic acid, oleic acid, linoleic acid, linololic acid. So basically, this is the ratio. This is a profile. Give you this ratio or this fraction, molar fraction. What would be the average molecular weight of the oil? If we know the molecular weight of the oil, so we can actually say, yeah, I need actually 3 moles of alcohol, methanol, to each of this 1 mole of oil. And in this case, I'm done with calculating the theoretical amount of alcohol needed for the oil. Okay, how to do this? Again, we have the molecular weight for each of this type of fatty acids. And of course, this can be calculated easily. So we have to use the equation here. So basically here, to calculate the average molecular weight of fatty acids in the oil, in the soybean oil in this case. So 1 divided by, or the reciprocal of molecular weight of the average molecular weight of soybean equal to the summation of mole fraction of each of the fatty acids contained in the oil divided by its molecular weight. We know from the previous table that we have 9% of palmitic acid and 4% of stearic acid, and so on and so forth. So basically, we divide the 9% divided by the molecular weight of this fatty acids plus 4% divided by the molecular weight plus 22% divided by the molecular weight, and so on and so forth. So basically, you get this kind of value, and therefore the average molecular weight of the oil is 278.6. Then we have to calculate the average of the molecular weight of the oil itself. So basically, to get this is basically the average of fatty acids, the average as if it's actually one average fatty acids in the oil, but in reality, it's different from one to another. So basically, we get just the average value for the fatty acids in this case. Okay. So to calculate the average molecular weight of soybean, we have to use again this equation, and we said that this came from the hydrolysis of fatty acids of the oil, and it's equal to the 3 times the average molecular weight of fatty acid, which we just calculated here from this equation, plus the molecular weight of glycerol minus 3 molecular weight of oil of water. In this case, we have 3 times the 278.6 plus 92.09, which is the molecular weight of glycerin, minus 3 times the molecular weight of water. With that, this will just get the average molecular weight of oil, and it is 873.7 kilogram لكل كيلو mole, or basically gram لكل mole. And if we have this value, we can calculate how much oil, how much ethanol we need to have this kind of transesterification reaction. Okay. So say we have 1 molar, so basically we can actually 3 molar of methanol. We can just easily calculate that we have to have 1 mole here. In this case, we have to have 873 gram of oil plus the 3 moles of methanol. So basically 3 times the molecular weight of methanol divided by 1 mole in this case is 873 gram per mole of the oil. Okay, I hope this is actually useful, and see you next time. Thank you.